Hello everybody. Now I am going to discuss the chapter that is heat. Heat is a form of energy which flows from a hot body to a cold body when they are kept in contact. The SI unit of heat is joule, and the symbol of to represent joule is capital J, and the other common units of heat are calorie and kilocalorie. 1 calorie is defined as the heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius, whereas 1 kilocalorie is the heat energy required to increase the temperature of 1 kg of water by 1 degree Celsius. So now I am going to discuss the relationship between different units of energy. So 1 kilocalorie is equal to 1000 calorie. 1 calorie is equal to 4.2 joule approximately, and 1 joule is equal to 0.24 calorie. Now the next topic is temperature. Temperature is a quantity which tells us the degree of hotness or coldness of a body. When a body is heated, its temperature rises, and when it is cooled, its temperature falls. The SI unit of temperature is Kelvin, but generally temperature is measured in unit degree Celsius, and this is the way to represent the degree in short form. Clear? Another unit of temperature is degree Fahrenheit, and this is also written in short form like this. Always we write Kelvin in the symbol form capital K. We don't write degree K. Clear? Now, the device that is used to measure the temperature of a body is called thermometer. A thermometer works on the thermal expansion of a liquid. The most common type of thermometer which we use in the laboratory is Mercury thermometer, and it is very clear in the diagram that it consists of a glass capillary tube with a bulb at one end. The bulb is filled with mercury. The long part of the capillary is called the stem or red arrow. The stem has the markings from -10 degrees Celsius to 110 degrees Celsius with 120 equal divisions in between. Its zero mark, which is called the ice point or the lower fixed point, is at the level of mercury in the capillary when its bulb is kept in the melting ice, and the 100 mark which is called the steam point or upper fixed point is at the level of mercury in the capillary when the bulb is kept in the boiling point. Means ice point when we keep the mercury in the ice, clear, and melting ice, and the upper fixed point or the steam point when we keep the mercury, means bulb of the mercury in the boiling water. Okay. Now scales of a temperature. Generally we use the following 3 scales of temperature. First, the Celsius scale, second, the Fahrenheit scale, and third, the Kelvin scale. Now I am going to discuss in brief separately about each scale. So the first is Celsius scale. The Celsius scale was introduced by the scientist known as Celsius, and on this scale the ice point is marked as 0 degrees Celsius. It is very clear in the diagram also. And the steam point means what? Upper fixed point is marked as 100 degrees Celsius. And the interval between the ice point and the steam point is divided into 100 equal parts. So you can see in the diagram 100 equal parts are there, and each means 100 equal divisions are there, and each division is called 1 degree Celsius. Clear? Next is the Fahrenheit scale. This scale was introduced by Fahrenheit. Fahrenheit is the name of the scientist, and this scale is generally used for clinical purposes. Clear? Means in day-to-day life also we use Fahrenheit scale for Fahrenheit thermometer to measure the temperature of the body. On this scale, the ice point is marked as 32 degree Fahrenheit, and the steam point is marked as 212 degree Fahrenheit. The interval between the ice point and the steam point is divided into 180 equal parts, and each division is called a degree Fahrenheit, and is written as degree F. Now the next is Kelvin scale. Kelvin scale was introduced by the scientist Kelvin. It is also called the absolute scale of temperature. This scale has no negative temperature. The ice point is marked as 273 Kelvin and the steam point is marked as 373 Kelvin. The interval between the ice point and the steam point is divided into 100 equal parts, and each division of the Kelvin scale is equal to that of the Celsius scale. Clear? Now I am going to discuss the comparison, means I am going to compare the all three scales of temperature: Celsius scale, Fahrenheit scale and Kelvin scale. So you know the symbol, clear? So ice point, when we take Celsius scale, then the ice point of Celsius scale is 0 degree Celsius. Ice point of Fahrenheit scale is 32 degree Fahrenheit, and the ice point of Kelvin scale is 273 Kelvin. Same way, steam point of Celsius scale is 100, steam point of Fahrenheit is 212, and steam point of Kelvin is 373 Kelvin. So when we talk about the number of divisions between the ice point and the steam point, then the number of divisions between the ice point and steam point in Celsius scale is 100, in Fahrenheit scale is 180, and in Kelvin scale is 100. Okay. Now the next is the effects of heat. So heat produces mainly the following three effects: change in temperature of the body, change in size or shape of the body, and change in state of the body. So now I am going to discuss in brief about the all three effects. So number one, change in temperature of the body. When a body is heated, its temperature rises, and when it is cooled, its temperature falls. The change in temperature of the body depends on the quantity of heat imparted to the body. Clear? Quantity of heat imparted means the quantity of heat given to the body. Next is the material of the body. You must have noticed that some material get heated very fast and some material means do not get mass of the body. So you must have noticed that it is very easy to heat small quantity of any substance, anything, and it takes much heat when we heat large quantity of anything. Clear? Now the next is change in size of the body. When a body is heated, it expands, and when it is cooled, what happens? It contracts. The change in size of the body due to heating is called thermal expansion, and about the thermal expansion I'll discuss in another video in detail. Clear? Because this topic is very important and very interesting also. Next is change in state of the body. This is also very important. Clear? Here I'm going to explain you with the help of this diagram. So you can see here, first I'll tell you that what is change of state. The process of change from one state to another at a constant temperature is called change of state. So when a solid is heated, it changes into its liquid at a fixed temperature, and changing of solid into liquid is called as what? Melting or fusion. And the reverse of this process is called freezing. You can see this is what? Freezing. And in this, what happened? The liquid freezes into solid at the same fixed temperature. Now next is condensation. Clear? So first I'll discuss about the vaporization. When a solid is heated, it changes into its vapor at a fixed temperature, and this is called vaporization. And opposite, means reverse of this process, is called condensation. In condensation, what happens? The vapor condenses into liquid at the same fixed temperature. Clear? Now when a solid on heating changes directly into vapor at a fixed temperature, the process is called sublimation. Clear? And similarly, the change directly from vapor to solid at fixed temperature is called deposition. Means we can say that the sublimation and deposition are opposite to each other. Clear? The change of state from liquid to gas at all temperature is called evaporation. And now I'm going to discuss the difference between the evaporation and boiling, and this is very important. So the first difference between the boiling and evaporation is that boiling occurs at a fixed temperature, whereas evaporation takes place at all temperature. Because when you keep the water in a bowl and you keep it in open, then what happen? It get evaporated. So no fixed temperature is required for that. It means evaporation takes place at all temperature. But when you boil something, when you boil water, then it occurs. For example, I'm taking water. The water boils at what? 100°C. So means we can say that the boiling occurs at a fixed temperature, but evaporation takes place at all temperature. Second difference is that boiling is a rapid process. Rapid process means what? Fast process. It occurs very fast. But evaporation is a slow process. Like if you will keep the water in a bowl and you will keep it on the roof, then what will happen? Slowly it will get evaporated. It takes 1 hour also, 2 hours also. It depends that how much heat we are getting from the sun. So this is the basic difference between the boiling and evaporation. I hope all the topic must have become very clear to you. Next topic I'll discuss in the next video. Till then, have a nice day. Thank you very much.